Hi, welcome to Concept Capsules. The topic that we're going to look at today is NPV and IRR. Now, both of these techniques are the most important capital budgeting techniques that we're going to look at in the CFA as well as the FRM curriculum. Now, of course, both of these techniques would be much more used in CFA because you will come across these in your level 1, level 2, as well as your level 3 examinations. So let's understand how to use these techniques and what are the difference between the two. And we look at a couple of examples as well on how to solve this and how to use the BA2 Plus calculator to be able to solve the NPV and the IRR. First, let's look at the net present value, NPV. Now, what do we really mean by NPV? Now, the name itself suggests that it has got something to do with present value. So it's a capital budgeting technique which helps us compare cash flows that are occurring at different points in time so that we are able to determine which is the best project to execute right now. So if you're working with multiple projects, let's say project A, B, and C, and we want to see that which project should we go in for with our limited capital, then NPV will help us in determining that. It also helps us in determining the sequence in which we should be executing the project, even if we have more money with us right now. So NPV is a way to evaluate how profitable that project really is based on after-tax cash flows. Now, how do we calculate the net present value? Now, it's an application of your timeline as well as the present value concept, just that we have an additional thing to do here, which is netting the cash flows out. So we have two different kinds of cash flows in any project. We are looking at inflows and outflows. Outflows essentially means that is the investment that we are putting into a project. So that is the money which is going out from our pocket. Inflows is the return that project is making for us. So that is the amount of money that the project is generating. So how profitable the project is will depend upon whether we have more of inflows or more of outflows. So essentially in net present value, what we do is we net out the inflows and the outflows to see whether we are getting a positive figure or a negative figure. The difference here is that we understand that we cannot exactly compare the cash flows occurring at different points in time. So if a cash flow is occurring at point 1 versus point 2 versus point 3, then we can't simply add or subtract them. We will have to get it to a common platform. And that common platform is the time when you're making the decision, that is time period 0. So we get all the cash flows to time period 0, and that's where we compare them. So let's have a look how to do this. Now, if you see the formula is essentially that you take in all the cash flows and you discount them to time period 0. So here is an example of a timeline. You have a project for which you have to pay 100 right now. So that is the outflow, minus 100. This is a project that is generating 20 in year 1, 30 in year 2, 60 in year 3, and 80 in year 4. Now, on the face of it, it looks to be quite profitable. The other thing that you need to know for calculating the NPV is a discounting rate. So that's a rate which we will need to calculate. Now, in your questions, mostly that is something which is given to you, but practically speaking, whenever you're using NPV, you have to calculate the discounting rate yourself. Now, how do we compare all of these cash flows? We get these cash flows to the same time period, and that is time period 0. Now, why are we specifically choosing time period 0? Because we are going to make the decision today of whether we want to accept or reject the project. So that's the reason why all the cash flows have to be brought back to time period 0. How do we do this? We take 20, we choose whatever the discounting rate is, let's say 5%, 8%, 10%, whatever the figure is, and we discount this for 1 year to get present value 1. Similarly, we take 30 and discount it for 2 years, 60 discounted for 3 years, and 80 and we discount it for 4 years. Now, once we have all of these cash flows, we add them up together because we are talking about time period 0. From this, we are going to subtract the initial cash outflow, which is 100. Because now all of these cash flows are comparable because all of them are now effectively occurring at time period 0. So now they're comparable. So we simply net out the initial cash outflow we see what is the net figure that you're getting. Is it a positive figure or a negative figure? Now, of course, in this case, we only have a single cash outflow, but practically speaking, it's not necessary that you only have one cash outflow. The cash outflow could occur later on as well. Maybe you require additional investment into the project. So whatever the sign is, we take the sign as it is, we simply discount all the cash flows and then net them out together at time period 0. And that is what our NPV is going to be. Now, what is the NPV rule? How do we decide whether we want to accept or reject the project? That is where your decision rule comes into the picture. If your net figure, the NPV figure, is positive, then that project is something that is profitable, that is something that is adding value to the company. So it increases the firm value and you should accept it. So if your NPV is more than 0, then you should accept the project, which means you should invest in the project. If it's less than 0, then you should not invest. So if the NPV is more than 0, that means it's adding value to the company. If it's less than 0, that means it's destroying the value for the company. But what happens if the NPV is exactly equal to 0? That means it's neither adding nor destroying the firm value. So you're indifferent. Indifferent means that you could accept it or you could reject it. It's not going to make a difference. So yes, theoretically speaking, you're indifferent, but practically speaking, you're not going to waste your time and effort on doing a project which is not going to add a value. So theoretically speaking, we are indifferent, but practically speaking, you're not going to execute that project. So that's how NPV works. Now let's look at the next technique, that is the IRR, internal rate of return. Now, internal rate of return is the second technique that we use. Now, the advantage of using this technique is that we don't need to have a discounting rate. We only need to work with the cash flows. So it has lesser amount of information requirement compared to NPV. So that's one advantage over NPV that it does have. Now, in IRR, we actually go ahead and calculate the discount rate. Now, put simply, the relationship between NPV and IRR is that IRR is that discounting rate which makes NPV is equal to 0. In other words, it means that is that specific rate that equates the present value of cash inflows to the present value of cash outflows. So we are not given a discounting rate here. It's actually the discounting rate that we are calculating. So IRR makes the present value of cash inflows equal to the present value of cash outflows. So what is the formula here? This was the original formula that we used for NPV. It is that rate which is making NPV equal to 0. So we simply equate the entire expression to 0. Now, what is the IRR rule? How do we decide whether we want to accept or reject the project using IRR? Now, a requirement for using IRR is that we want to have a hypothetical hurdle rate that the project needs to earn at least this much return so that we are able to accept or reject it. Typically, it would be comparable to your cost of capital. So the decision rule for the IRR is that if your IRR exceeds your required rate of return for the project, which is popularly called as the hurdle rate, then you accept the project. If it is lesser than your hurdle rate, then you do not invest. That means you reject the project. So that's how we use the IRR concept. Now let's look at how to calculate NPV and IRR. So let's look at this example. Suppose you have company A that is considering an investment of 100 million in a capital expansion project that will return after-tax cash flows of 20 million per year for the first 3 years. And another 33 million in year 4, which is going to be the final year of the project. So remember, it is a 4-year project. Right now, you have to put in 100 million. So minus 100 is your cash outflow at time period 0. Then you're going to make 20 million every year for the first 3 years. So minus 100 followed by 20, 20 and 20 for year 1, 2 and 3. And in your last year, you're going to make 33 million. So those are the cash flows that you have from this project. If the required rate of return of the project is 8%, so that is your discounting rate that we will be using for the NPV calculation, what would be the NPV and IRR, and should the company undertake this project? So we need to calculate the NPV, IRR, and then we need to decide that should we or should we not go ahead and execute the project. So let's see how to do this. Now, whenever you're working with NPV, IRR questions, or basically any time value of money problem, it's always helpful to draw a timeline. So let's do that. So this is going to be your timeline. Minus 100 is going to be your cash outflow. 20, 20, and 20. Remember, first 3 years, this is the cash inflow that you're having, followed by 33. Also, remember that your discount rate is 8%. Now, how do we go about calculating the NPV? We can't compare minus 100 to this 20, this one, or this 33 directly. So we cannot net out the cash flows like this. We always have to do it on a present value basis. So we take all of these individual cash flows, so the 20 occurring in year 1, we discount it to year 0. This 20 again discounted for 2 years, this one for 3 years, and 33 for 4 years. Once we have done that, we add up all the cash inflows, the present value of the cash inflows, and we subtract the cash outflow that was occurring in time period 0, and that is what our NPV is going to be. So this is how we will do this. 20 divided by 1.08 raised to the power of 1 divided by 1.08 raised to the power 2, because 8% is our discounting rate, minus 100. And these are the values that we are going to get. So 20 in present value terms for 1 year is 18.5. Similarly, this 20 goes down to 17.14 and so on. So we have these 4 cash flows. These are the present value of cash inflows, and this is your outflow. So how do we calculate the NPV? Net present value. That means you will net out the outflows from the inflows. So this is your present value of inflows. We subtract 100 from that. So that's why we have done this minus 100 part, and we get a value of minus 24.2 million. So that's how we can calculate the NPV here. Now, the next thing that we are asked to calculate is the IRR, the internal rate of return. Now, how do we calculate the IRR? So remember, IRR is that discounting rate that makes NPV is equal to 0. So this expression that we have here, this is what we will equate to 0, and we will keep the rate, the discounting rate, as an unknown. So instead of 1.08 to the power of 1, this becomes 1 plus IRR raised to power 1. IRR is what we have to find out. Similarly, 1 plus IRR raised to power 2 and so on. So we keep the rate as an unknown and we try to calculate that. This is the kind of expression that we are going to end up with. So the same equation with unknown interest rates, that is basically the IRR. We have to subtract 100 here as well. And we equate that to 0 because IRR is that rate that makes NPV equal to 0. Now, once you have this equation, this is something that is not easy to solve because you have IRRs in the denominator. So it's not a straightforward equation to solve. If you're doing it manually, then you will need to use the trial and error method and ultimately go in for interpolation. So that's going to take quite some time for you in an exam condition. Now, luckily, we don't need to do NPV or IRR manually because we already have the BA2 plus calculator. So instead of trying to do, trying to discount every single cash flow, we simply input all of these cash flows into our calculator and calculate NPV and IRR directly in one go. Now, how do we do that? Let's try it out. So that's your BA2 plus calculator. We put in all of these cash flows here. Now, how do we do that? You have minus 100, which is your cash flow occurring at time period 0. So you go to CF. Now in CF, here, of course, by default, you will all have 0. So this is where you need to put in the values. Also, once you put in the values, remember to press the enter button. So that's quite a common error that happens, that you forget to put in, press the enter button. So it still remains at 0. So CF0 is going to be 100 and it's a negative. Once you're sure of the value, then press enter. Then you press the down arrow key. Now it's asking you for the other cash flows. Now, usually what we would have done would be, we will take all of these cash flows, so 20, 20, 20, and 33, and we keep entering all of those. Now, in this case, we can clearly see that 20 is occurring more than once. It's occurring thrice. So rather than putting 23 times, what we do is we put 20 here, we press an enter. When you press the down arrow key, we see F01. F is basically for the frequency. How many times is that cash flow occurring? Now, it's by default 1 because the assumption is that cash flow is occurring only once. So if you don't want to use frequency, what you will do is you will leave it like this. You'll go to C002, again put in 20, again go to C03 and put in 20. But here, since we can change the frequency, let's take advantage of that. Now, how many times is 20 occurring? That's 3 times. So we change the frequency to 3. Again, press enter. That means 20 has occurred thrice. So we don't need to do it 3 times anymore. What is the next cash flow? That is 33. So that goes here and press enter. Now we simply go ahead and calculate the NPV. So compute NPV. When you do this, it's asking you for the discounting rate I. That is 8%. Now you have to keep in mind that you have to just press 8 and enter. Do not put it as 0.08. Do not put 8 and then press percent. This automatically takes it in percentages. So we don't need to do anything else here. If it's 8%, just press 8 and press enter. Then we go to NPV, put the down arrow, and you see by default it's showing 0. All that you need to do is press compute. And you see it's giving you minus 24.2. That's the same answer that we got here. So minus 24.2 million. So we did not have to go through this long drawn process. We simply put in the cash flows and get our answer in one step. Similarly, we can calculate the IRR. So you go to compute, IRR, it's showing 0 right now. Simply press compute again, and it shows you minus 2.63. That's what we have here, the IRR. Now we can see that it does not make sense to go in for a negative negative NPV project or a negative IRR project. So the decision is quite clear that we reject the project. It's negative NPV, it's destroying the value for the company. So there's no point of going in for this particular project. All right, now let's look at the next concept. Now the ranking conflicts between NPV and IRR. Now usually NPV and IRR will agree on the final outcome because we typically look at projects that are independent and projects that have conventional cash flows. Conventional cash flows means that the sign is changing only once. So you have negative followed by positive. So for such projects, NPV and IRR will give you the same conclusion. However, if you have two mutually exclusive projects, sometimes you could get conflicting answers. So NPV would suggest one project, IRR might select another project. So in that case, what do? Whenever there is a conflict between the two, you always go with what NPV says. So you don't select IRR, you go with what NPV has said. That is the final answer. Now, in some cases, it's also possible that you have a problem that is called as multiple IRR or no IRR. Typically, this is something that is going to happen when your cash flows are non-conventional. Now, what do we mean by non-conventional? Non-conventional means that your sign, the signs of the cash flow keeps changing from minus to positive and back. So the sign change is occurring more than once. So let's say you have at time period 0 negative cash flow, then you have positive followed by another negative and then positive and so on. So when the sign is flipping more than once, that is a non-conventional cash flow pattern. Now in such cases, IRR struggles to give you an answer. So these are the cases when it's best to go in with what NPV says. So just stick to NPV for these scenarios and you'll get your answer. Now, why does this really happen? Why do NPV and IRR end up giving you different answers in such scenarios? Now, the problem really happens because of your reinvestment rate assumptions. So for instance, NPV assumes that your reinvestment is happening at whatever your discounting rate is. IRR assumes it happens at the IRR rate. Then you could have different project sizes and you could have different cash flow patterns, conventional and non-conventional, what we just discussed. So this gives rise to the ranking conflicts. Now let's have a look at another example. Now suppose you have three independent projects, X, Y, and Z. Assume the hurdle rate is 12% for all the three projects. Their NPVs and IRR are shown below. Now for project X, Y, and Z, the NPVs are 20,000, 21,400, and 23,000. IRR is 20, 32, and 18. Now if we look at NPV, all the three have positive NPVs. So all of these three will still add value. How about the IRR? Your hurdle rate is 12%. And you can see all the three projects have easily cleared that hurdle rate. So you're getting more than 12% in all the three cases, which means all the three projects are viable. But we need to select one single project. So if the projects are mutually exclusive, which of the following is the most economically feasible project? So how do we select one project out of these? Now here, you can see that the highest NPV is in project Z, which is 23,000. But the highest IRR is in project Y. So again, this is a case of conflicting conclusions given NPV and IRR. Now, whenever NPV and IRR are not agreeing on the final outcome, the rule, as we just said, was that we go with what NPV says. So in this case, we ignore the IRR outcome. We look at what NPV has said, and highest NPV is for project Z. So this is the project that we select. So the answer is A. So all three are acceptable if they were independent projects, but they are mutually exclusive. So you need to select only one. There is no other option. So we go in for the highest NPV, not the highest IRR, and that's project Z. So that was all about NPV and IRR and how we calculate it. Now, this is something that you need to practice more, and make sure you also spend some time on understanding the conventional and the non-conventional cash flow pattern, and how NPV and IRR are different, and why there is a difference sometimes in the conclusion of NPV and IRR.